Greetings, ladies and gentlemen. In this video, we are going to answer this question, and it is coming from Science Paper 2, 2024 GCE. Okay, exam is just around the corner, so therefore, we need to be extremely serious. Without wasting much of our time, let us begin. Question C3. The following table shows the soil pH ranges required by different crops for growth. The first column we have crop, the second column we have pH range, and we have the list of crops here: peanut, millet, sunflower, paprika, mango. The first question, which is question A farmer plants peanut and millet crops. Only the peanut grows well. Question A, Roman numeral 1. Predict the pH of the soil. The question is carrying 1 mark. So they want us to predict the pH of the soil. So the first thing that we are going to do is to look at each and every pH range given here. So the pH range of peanut is 5.0 to 6.5. The pH of millet is 6.0 to 6.5. Okay. Now we want to give the pH. Let us give the prediction. So to give the prediction, the first thing that we are going to do is to look at the pH of the to look at the pH. So we need to remember that from 1 to 6, 1 to 6 on the pH scale represent acid. Then 8 to 14 represents base. 7 represents neutral, or 7 shows neutral. Okay, so peanut thrives or survive in the pH range 5.0 to 6.5, while millet requires 6.0 to 6.5. So if millet fails to grow properly, the pH is most likely between 5.0 and 5.9, suitable for peanut but too acidic for millet. Okay, so to give the prediction, we are going to say the pH of the soil is most likely between 5.0 and 5.9, suitable for peanut but too acidic for millet. Okay, we are done with this question. We shift to the next question, which is question A, Roman numeral 2. Which other crop is most likely to grow well in the same soil? So the prediction that we have given is that the soil pH is obvious, or the soil pH is most likely between 5.0 to 5.9. 5.0 to 5.9. Okay. So which crop will grow in the same soil? Since the pH of the soil is likely between 5.0 and 5.9, mango is most likely to grow well in the same soil, as it has the pH range of 5.5 and 6.5. So according to the pH given in the table, so we have seen that mango is the one that is most likely to grow under this pH, according to the prediction we gave in the previous question, which is question A, Roman numeral 1. Okay, so our answer here is mango. We move to the next question, which is question A, Roman numeral 2. Question A, Roman numeral 3, Question A, Roman numeral 3 suggests what should be done to the same soil by the farmer in order for him to grow paprika. Okay, so in order for this farmer to grow paprika. Paprika has the pH of 7.0 to 8.5. The farmer should raise the soil pH should raise the soil pH by applying agricultural lime such as uh, uh, Caucitic lime. By the way, Caucitic lime is a common name. Scientific name, calcium carbonate, or applying dolomitic name, dolomitic lime. Dolomitic lime is also a common name. Scientific name, calcium magnesium carbonate. So to raise the pH, of the soil from 5.0 to 5.9 to this pH, we need to add lime to the soil. Okay, or using wood ash sparingly to increase alkalinity, or we can use uh, or we can add crushed eggshells for gradual pH increase. So all these are alternative ways or alternative measures that we can consider to increase the um, pH of the soil suitable for paprika. So we are going to say to grow paprika, the pH 7.0 to 8.5. The farmer should raise the pH by applying agricultural lime. So we have talked about these limes. Okay, so these are some of the measures that this farmer need to take. We move to the next question, which is question B. Ammonium nitrate is one compound which is added to the soil by many farmers. Explain why ammonium nitrate is added to the soil. Explain why ammonium nitrate is added to the soil. Ammonium nitrate is a fast-acting nitrogen fertilizer. Okay, number one, it supports plant growth, essential for proteins, chlorophyll, and DNA. It works fast, water soluble, ideal for crops like wheat and maize or corn. Balance nitrogen. So it helps to balance nitrogen. So therefore, we are going to say ammonium nitrate is a fast-acting nitrogen, or it provides the soil with nitrogen necessary for plants growth. Okay, necessary for plants growth. We move to the next question, which is question C. Question C, the diagram shows part of nylon, a condensation polymer. Roman numeral 1, deduce the chemical formulae of two monomers in nylon. Deduce the chemical formulae of the two monomers in nylon. The question is carrying 2 marks. Okay, the question is carrying 2 marks. So we are going to say nylon is commonly made by condensation polymer of two monomers, dicarboxylic acid and diamine. So these are two monomers of nylon. These are two monomers of nylon. So for nylon 6,6, the two monomers are xn 1,6 diamine or diamine, and the chemical formula is H2N open bracket CH2 close bracket 6NH2N. Okay, we are also going to look at this one, xn dioic acid or adipic acid or dicarboxylic acid. The chemical formula, we have HOCC or COOH. Even here we have COOH. So we have this group here, which is CH2 4 surrounded by these two. So these two monomers react to form nylon and water. So therefore, we are going to say XN1,6 diamine. The chemical formula is here. So this is the chemical formula, and the dicarboxylic acid. So this is the formula of dicarboxylic acid. We are done with this question. Let us move to the next question. We move to the next question, which is question C, Roman numeral 2. Question C, Roman numeral 2. Draw the displayed molecular structures of the two monomers. Draw the displayed molecular structures of the two monomers. Okay, so this is what we are going to do. Diamine. The first thing that we are going to do, we are going to draw this one here. First, we are going to draw this one. Then this one is surrounded by NH2. Okay, so let us do as wise. So we can see that here we have 6 atoms of carbon and we have 12 atoms of hydrogen. So let us draw 6 atoms of carbon. Draw 6 atoms of carbon. So we can see that we have 6 atoms of carbon. Then these 6 atoms of carbons are surrounded by 12 atoms of nitrogen. 12 atoms of nitrogen are surrounded by 12 atoms of nitrogen. Okay. Then we can see that this group is surrounded by NH2. So we are going to draw NH2 here. NH2 here. We are also going to draw NH2. Okay, sorry, NH2. So we can see that this one here, the mid part is surrounded by 2NH2. Okay, 2NH2. We are done with this question. Let us see. Alternatively, we can also use this method here. Let me do this. We can also use this method here. We can just draw this box or rectangle. Then this one will be surrounded by NH2. This one also surrounded by NH2. So you can also draw it like this. So this is what we are going to do when drawing dicarboxylic displayed formula. So we are going to bring a box here. Then this box will be surrounded by COOH. Okay, COOH. Here we have COOH. Even here we have COOH. So this is the structural formula. So we have successfully managed to draw the structural formula. We are done with this question. Let us move to the next question. We move to the next question, which is question D. Fish nets used to be made from natural fibers. Men nets are now made from nylon. Suggest one advantage and one disadvantage of using nylon rather than natural fibers to make fish nets. Okay, so this is the reason that we are going to give. We are going to say number one advantage. Nylon is stronger and lasts longer than natural fibers. So the fish net won't break easily. So we have given the advantage. Now let us also give the disadvantage. So to give the disadvantage, we are going to say nylon does not rot or break down easily. So if lost in water, it can cause pollution or harm animals' aquatic lives. So this is the disadvantage. Okay, so ladies and gentlemen, we have come to the end of this question.